The impacts of wastewater discharge into the natural environment has contributed to standardizing the main pollution parameters. What are the different parameters that characterize pollution? We will study suspended solids, then BOD5 and COD, and lastly, nitrogen and phosphorus. Matter that is likely to be deposited at the bottom of a river is characterized by SS, suspended solids. Following the filtration or centrifugation of a water sample, the matter that has been collected is dried. This enables us to determine the weight of the matter that clouds water and risks creating deposits. Then an analysis allows a distinction to be made between mineral matter, MM, and organic or volatile matter, VM. We can also examine suspended solids further and determine the fraction that can settle and be responsible for the deposits. Instead of conducting a filtration or centrifugation in order to isolate this matter, a cone designed for settling the solids can be used. To characterize the deficit of dissolved oxygen linked to wastewater discharge into a river, a 5-day biochemical oxygen demand analysis is carried out. It is written BOD5. What occurs in a river is reproduced in the laboratory by mixing in a flask a small quantity of wastewater and clean water saturated in dissolved oxygen. After 5 days in total darkness, the level of concentration of residual dissolved oxygen is measured, and by doing so, the quantity of dissolved oxygen consumed in the flask, as well as the river, can be deduced. This is the BOD5. This analysis calls upon biological phenomenon, and therefore takes a long time. It enables biodegradable pollution to be characterized. Pollution that can be oxidized is partly biodegradable by microorganisms and partly not biodegradable. An analysis using chemicals enables all the biodegradable and non-biodegradable oxidized pollution to be quickly accessed. This is called COD, or chemical oxygen demand. This is pure chemistry, via rapid heat oxidation for 2 hours. The COD takes into account organic matter that can be oxidized regardless of whether or not it is biodegradable. The COD is always higher than the BOD5. Wastewater contains nitrogen in its reduced form, ammonia NH4+, and its organic form, resulting from human activity, mainly urine. Discharged into the river, this nitrogen can reveal itself to be highly toxic under certain pH conditions. Nitrogen also participates in the consumption of oxygen over long distances due to the slow biological transformation of nitrates. These two types of oxygen consumption are added together, giving the red curve. Urine is also rich in phosphorus, the discharge of which into the natural environment participates, along with nitrogen, in plant and algae development. An excess in plant development can lead to serious problems in a river's equilibrium. This is called eutrophication, which partially affects estuaries and seashores. Eutrophication is due to an excess of nutrients, nitrate and phosphate. This process can be natural or be the result of human activities, runoff from fertilizers, discharge of wastewater. It causes an excessive multiplication of certain algae in the aquatic environment, sometimes leading to green tides phenomena. What you need to remember about pollution. The pollution parameters to be monitored in the first instance are suspended solids, BOD5 and COD, globally representing matter that can be oxidized, and finally, nitrogen and phosphorus in their various forms.